And I will go into week 2 lecture. If you have any questions, just speak up, because I have difficulty monitoring the chat when I go through the slides. So it's better if you can just unmute and ask questions.
I have a question, but it's more general for the course.
Sure.
Would you be open to opening up the other weeks so that we can work ahead a little bit if we have like busier weeks throughout the summer? Because I know a lot of us are working and trying to like balance kids and family.
So usually I do that after week 4, and I'm still very busy. So sometimes I still couldn't work ahead that much. So I was unable to modify a lot of things. So I'm pretty much just a week ahead. So if I can, because I always change some of the quiz questions and practice questions, etc. So I still need some time to work on those things. But if I can, I try to open up everything halfway through.
Okay, thank you.
But I will try. If I can, I certainly will do that. Okay, so last week we focused on descriptive statistics, right? We said descriptive statistics is really for describing a set of data that you have already collected. But starting this week, we will move into inferential statistics. As you see from the name, it really inferring from a sample to its population, right? So for example, if you would like to prove your prototype is going to work for all 3rd graders in the nation, and you are teaching, your prototype is to teach 3rd graders certain math skills, for example, then you need to do an inferential statistics to say that, okay, it worked in my 3rd grade class, but based on the statistics I run, it should work for its broader population. Then the inferential statistics comes in because you're inferring from the sample result to its population, okay? So I'm not going to spend too much time here because I think all of you really know population versus sample. And it's really subset of your population is the sample. The reason that we have to rely on sample is because it's almost impossible to include population, the whole population in your test or in your research. Okay, I believe you know that. So let's talk about the hypothesis testing. So whenever we have inferential statistics, we usually hypothesize because we are saying that this thing that worked for my 3rd grade will work for 3rd graders in the nation. Then that is a hypothesis, right? Because you don't know whether it's going to work or not. And you are testing that hypothesis using statistical procedure, right? So it's a statement about one or more population parameters. Such statements are either true or false. So let's take a look at some examples. So when you put hypothesis, hypothesis statement, there are 2 ways that you put it. One is we call it non-directional hypothesis. And non-directional hypothesis is you don't know which one is greater than the other one. For example, we would say your students took a pre-test before they use your 3rd grade math prototype. And then they will take a post-test afterwards. And probably the math prototype you created is kind of game. And some people say using game to learn math is effective for 3rd graders. But some experts say that this serves them because they are so concentrated on the gaming features rather than really learning the math. And that can actually disserve. So based on the literature, then you probably cannot definitely say your game that teaches third grade math will work or not. In that case, your hypothesis becomes non-directional because you don't know that whether post-test scores will be statistically significantly higher than the pre-test score, right? And you just want to know that whether there is a difference or not. In that case, the hypothesis is non-directional. And you state your null hypothesis. Null hypothesis is always noted as hypothesis 0. So that's null hypothesis. And its opposite, we call it research hypothesis or alternative hypothesis. In this case, the mu1 and mu2, this is a non-directional hypothesis. We say they are equal because non-directional hypothesis, you have to have the equal sign. Otherwise, mathematically, you cannot find a point to say whether this is the greater or less than. Okay, so let's go to the next one. I think when we get to a directional hypothesis, that becomes a bit more clear. So when your research null hypothesis is non-directional, your research hypothesis, which is hypothesis 1, is also non-directional. They have to be mutually exclusive because when you are making a conclusion, you always base on the null hypothesis. If you are rejecting the null hypothesis, you will accept the research hypothesis automatically. And if you are unable to reject the null hypothesis, then your research hypothesis is not accepted, right? Because they are mutually exclusive. So directional hypothesis is going in certain direction, right? So for example, if your hypothesis, your mu1 is, let's say it's probably the post-test score. And mu2 is your pre-test score. And you hypothesis that your post-test scores after they use the math game will be higher or greater than the pre-test score in this case. And it's easier to start with your research hypothesis and you state that first, and its opposite is your null hypothesis. These have to be mutually exclusive. And I realize some students go ahead and look at some Khan Academy and some videos outside, and they are not very scientific. So they are often not mutually exclusive. And that becomes a problematic. And that's actually wrong. So be careful when you are using external tutorials. Sometimes you may not see the exact way we are talking about here. If they are not mutually exclusive, we cannot make the conclusion. By rejecting that one, we are accepting the other one. We cannot make that conclusion, right? So this is directional hypothesis, and the one that you had over this one, this is the null hypothesis, and this one is the research hypothesis. That is non-directional research hypothesis. Okay. Any questions so far? I hope I'm not talking too fast. If you feel it's too fast, let me know.
One question. I'm seeing that you said that the non-directional, and then it says H1 equals mu not equal to 2. And if it's, not equal to mu 2. And if it's not equal to mu 2, it means it's either greater than or less than. So that would imply to me it's directional. So I'm a little confused because where it says research hypothesis, non-directional research hypothesis, shouldn't that be the equal sign versus directional, which would be the not equal sign? That's why I'm a little confused here.
The directional is always has either the greater or less than sign, right? For
right, I understand that.
You don't have that.
But look at the, oh, okay. So is number one in this slide directional?
It's non-directional because you don't have greater or less than signs, right? Because you're not hypothesizing either one is greater.
Okay, so but it doesn't have an equal sign either. It says it is not.
No,
equal,
this is put in two portions. And if you would like to put in one slide, you'll copy this over and they would always occur as a pair. So when you state your hypothesis, you always state like this. This should be together.
Okay,
Yeah, so I put it in 2 slides because I needed to explain the null first.
I
So
understand.
this,
So,
this is how you say H0 and H1 should occur at the same time.
okay, so that's basically showing the non-directional, it either is or it isn't. It's either a yes answer or it's a no answer. It's not a greater than or equal.
Yeah, because you are not hypothesizing which one is greater. You're just saying they are not equal.
Okay, thank you. I understand now.
Yeah, and if you look at this, are also mutually exclusive, right? This one, oops, this one should be smaller 0.
Yeah,
Ah,
understood that.
it's a formatting issue here. So they should always occur as a null hypothesis and research hypothesis. Students often struggle to come up with the null hypothesis first. So the easiest way is always state your research hypothesis, also called alternative hypothesis first, and then its opposite is your null hypothesis. And statistically speaking, you have to reject the null hypothesis in order to accept the research hypothesis.
I have a quick question. Is H1 the same as HA or the alternative? Is that what you were saying earlier?
We usually do not use HA. You can. So H1 is research hypothesis. Its research hypothesis is also called alternative hypothesis.
Okay.
It's alternative to the null hypothesis.
Okay, perfect.
Yeah.
Thank you.
So this is dichotomous. It's just one or the other, and they are always mutually exclusive. So when we get to more concrete, the concrete examples, I think this will make much better sense. And sometimes this is the case for pre and post test. We are giving examples because you will be using that a lot. But sometimes if you already know a population mean, for example, you would like to see that your third graders, you only have one test, and you would like to see that whether your third graders compared to the nationwide third grade standardized test, whether there is a statistically significant difference. And that number is probably already given to you, for example, SAT. And let's say the SAT nationwide average is like 1,200. And you would like to know your school's 200 graduates compared to the nationwide number, whether there is a statistically significant difference or not. Then in that case, you are comparing your mean score against a decisive or a concrete number, and that's okay too. So that kind of t-tests, you can run that as well. But in our case, we will make it simple, and you usually have 2 groups of numbers to compare pre and post test scores. So I mentioned several times about statistical significance. So you may be wondering why there is such a word or such a phrase called statistical significance. Because the idea is that sampling is always imperfect. That means that sample may not ideally meet the population parameters. That's why we always say there is certain probability that, or certain level of probability is okay. That because of the sample does not perfectly match the population. So that's why we say statistically significant is saying that, okay, in what percent we are confident to claim the result we observe in our third grade math result will be true for the population. So there is always a probability involved. And we'll talk about the probability concept next. So the probability concept, we often call it p-values. The p-value is the probability of obtaining a value of the test statistic equal to or more extreme than that observed, given that the null hypothesis is true. So what does this really mean, right? So let's take a look at, for educational purposes, we often say that as long as 95% of the time, what I observed with my sample is going to be true for the population, I think we are okay with and we are happy with the result, and we say we have a statistically significant finding, right? So we call it the probability. In this case, we say p-value will be less than 5%. That really means 5% of the time that our conclusion could be wrong, because the sample is not perfect match of the population. That also means 95% of the time our result could work for the population. Okay. You can also say that 5% of the time, the result we observed could be due to the chance. And 95% of the time, it's probably not due to the chance. Because it's 90%, which is huge enough, we are confident to say this thing works 95% of the time. And this is p-value. The probability of a null hypothesis is in a given situation is less than 5 in 100. So when your p-value is smaller than 5%, you can reject your null hypothesis, because it's really saying that less than 5% of the time, this result will not be true, or it's due to the chance. Is this clear enough, or you have any questions?
Is the p less than 0.05, is that like a standard threshold where if it's less than that, you can, for the most part, reject the null hypothesis?
So that's what we call it. Conventional alpha level is 5% for educational usage. And it really depends on, sometimes people say this thing, if it works for 90% of the time, we are happy. So the p-value can be 10%. But if it's medical, for example, if you're testing a drug that is more serious, you cannot say, okay, 95% of the time the drug worked and it actually harmed 5 out of 100. And that's a serious problem. That's why in medical field, the p-value is less than 1 in 1,000 usually. So 999 out of 1,000 times it should work. And it's probably 1 in 1,000 times it may not work. And then that you can get the permission to widely use the drug, right? It really depends on the context, but in educational context, 5% is what our conventional p-value that we usually use as a threshold. Good question. Any other questions?
How large does the sample have to be?
It really depends on what you're testing. If you are only talking about t-test for your term project, as long as you have 8 or more students, you should be able to run a pre and post test comparison using a t-test. The more your sample size is better, but also it becomes more costly, right? You cannot really have a big sample size, and involving so many people to test can means a lot of resource that you have to spend.
Thank you.
So there is no definite answer. The sample size is always a question that you will have to look at your resources to make an adequate prediction. Like
for our group project, is there a goal in mind of how many students we have participate in order to make our
data more statistically accurate?
Yeah, so the larger your sample size, the more statistical power you'll have, the easier to reject null hypothesis. The smaller the sample size, you have to have a significant difference between the post-test and pre-test to comfortably say that there is a statistically significant finding. And we will talk about that when we get to the p-value, critical value and degree of freedom. So the degree
For
of
the
freedom,
project, is there a specific number for a group or individual project? Is there,
individual project for this class, you mean?
yeah, for this
Yeah.
class?
I usually prefer you to have 10 test subjects, but I can live with 8. When you
Okay.
have less than 8, it becomes very difficult to reject your null hypothesis because your degree of freedom, really sample size goes down, your degree of freedom goes down, and
Yeah.
you need to have a larger difference to prove this is not due to the chance, right?
Yeah.
Because if 1 in 10 people just did random things, that is 10% of your sample size. That could fluctuate your result significantly. And that due to the chance factor becomes huge.
Does everyone need to be tested at the same time in the same place?
No. For your term project, you don't need to do that. As long as they are not talking to each other. And usually that's the case. And it's better, especially if you are going to observe a subset of the people. For the term project, I prefer you to have 10 test subjects, but for the usability portion, you can just observe 3 to 5 students or 3 to 5 users. That's usually good enough. And you will learn more about the number, what is the appropriate number to use for usability test in week 5, I believe. So
Thanks.
yeah, we haven't talked about the term project yet, but I think we'll talk about that. We can talk about that a bit later, either at the end of this class or in week 3. And it's a good idea to get prepared for your term project early because you are not only going to design your instruments, all the measurement instruments you need to design, and also you need to conduct the actual evaluation, both level 1 and level 2 evaluations, collect data, and then you can analyze and report. So I usually ask students to start thinking about the prototype you're going to test, and then start talking to your test subjects to see that whether you can get people from your target audience. And oftentimes people have difficulty getting all 10 people from target audience. And I highly encourage you to start using your peers and help each other out. But they also have to meet the criteria. For example, if you are going to test addition for 3rd grade, your peers will not work, right? Because they already know addition. So their pre-test and post-test won't be valid to use. So it's very important to get from people from your target audience. It really depends on what you are testing. If you are teaching French and you have a lot of peers who never learned French, then they are a good target audience, right? So it needs some planning ahead.
So the information just has to be novel to that group.
Yeah, that's the ideal situation. Okay, so we just talked about the statistical significance, right? And besides statistical significance, we also have practical significance that you will be doing, right? Practical significance occurs when a research finding reveals something meaningful about what is being studied. So oftentimes you already have a statistical significant finding. But the question is it really meaningful in practice? So I think I have a long example in this class you can take a look at. And sometimes if you have large enough sample size, it's probably pretty easy for you to find a statistically significant difference. For example, let's say in my, yeah, I think this example is really comparing the hourly workers from a company in California and another company in Florida. And after comparing that, you find out the average age of California workers is 33 years and the Florida workers is 36. And this turned out to be statistically significant because your sample size is really large and representative. But the question is the 3-year difference is really due to the chance by sampling error alone, or is it really that meaningful, this thing is, right? So when it comes to this kind of questions, you would like to bring this practical significance concept into your discussion. So the practical significance, I believe you'll learn in week 4. We will bring in the effect size into the discussion. Okay, so keep in mind that one thing, that if something is has a practical significance, it has to have statistical significance first. But if your result is statistically significant, that does not mean it's practically significant. So when you have a statistical significant finding, you will run a practical significance test. If you do not have a statistical significant findings, you do not need to run a practical significant test because you don't need to go there. Okay. So another concept today is really important to understand is degree of freedom. And this thing is going to come up again and again in the next few weeks. So degree of freedom is the number of values free to vary, given one or more mathematical restrictions in a sample being used to estimate a population characteristic. So how do we understand the degree of freedom and why it's important, right? For example, we have a mass formula here. M, the variable M equals A, B, and C, and D, and E. You already know the value of M. And you are going to distribute and guess and allocate the numbers into these 5 categories, A, B, C, D, E. And you start giving them numbers, A, B, C, and D. And once you have these 4 decided, the 5th one is automatically decided because your sum is this M number value is already decided, right? So you only have 4 ways to vary your numbers because this 5th one is always has to be calculated based on the sum. So the idea of degree of freedom is like the number of values free to vary. And when we run statistics, this degree of freedom is important to understand because it comes with your sample size. So if, for example, you have 5 variables here, that's your sample size, then your degree of freedom is 4 in this case, right?
Is degree of freedom always calculated by like n-1?
Not
For your-
always. It's not
Okay.
always, and we'll talk about how they vary later. Yeah, it varies in different situations with different kinds of samples. But in general, it's usually n-1. But when you have 2 different sizes of samples for t-test, then the degree of freedom can vary. It really depends on also the variance. So it's a bit more, it could be confusing if I talk about this now. So let's wait later. But for now, you just say in general, it's n-1.
Okay, perfect, thanks.
Okay. So it's related to the critical value. Why we're talking about degree of freedom is it relates to critical value. How it's related is this way. Let's take a look at. So each test statistic has a critical value associated with a different degree of freedom. So this is the minimum value you would expect the test statistics to yield if the null hypothesis is indeed false. So let's take a look at an example. So I think I probably had a link somewhere. Hold on. Where is it? Oh, it's probably here. So degree of freedom and critical value, I think we can take a look at what the critical value tables look like. Didn't come up. For example, you're going to learn chi-squared this week, right? So this is a critical value table. So critical value table, you'll see that this is DF, it means degree of freedom. It really is related to the sample size. So the larger the sample size becomes, so you'll see, I think this is 5%, right? The alpha level 5% is over here. So this is chi-square, so it goes up. Oh, this is chi-square, so we are comparing more categories. This is probably not the good example. Let's see. So let's take a look at some of the, yeah, this one. So for example, you have 30 students, right? You have 30 students, and then you would like to see that whether your 30 students, they did well in their post-test compared to the pre-test after going through your prototype. So you see that the degree of freedom goes up, your sample size increases, right? When your sample size increases, your critical value goes down. These are the critical value. So critical value are the values that mathematicians and statisticians already calculated for you. So for example, if you say your confidence, your alpha level is 5%, and you want to conclude 95% of the time, the observed result from the sample will work for the population. And your degree of freedom is probably 29. You had 30 pairs of scores, 30 students, 30 minus 1 is 29, right? And as long as the difference between pre and post tests on average is larger than 1.699, then you have a statistically significant finding.
Is that 1.699%, or is that?
No, it's a t-test, t-statistics. So you will learn how to calculate this in week 3. Okay. So I'm just giving you an example how degree of freedom and critical values are related. So when your degree of freedom goes up, your sample size is larger, then you have more statistical power, and you just need to observe less difference in your comparison of pre and post test to get to a statistically significant difference. But if you only have 8 students, then your degree of freedom is 7, right? In this case, you'll have to have 1.89 compared to 1.6 something to claim that you have a statistically significant finding. because when you have 8 students, any one student's mistakes or errors can influence your result greater percentage-wise. So it's really the critical value is something that mathematicians will calculate for you. And that is one thing you're looking at when you're looking at the table. So it's okay if you do not understand all of this, you can go back and really read my slides, and I have a lot of examples and explanations, and that should make sense for you. And I would like to skip some of this and really get to the chi-square, which is the first inferential statistics that you are going to look at. And this one is a bit different than the things that we just discussed in terms of critical values, and I will explain. So what is chi-square test? Why do we need that? So chi-square test is needed when you have categorical variables. So for example, let's just go to this example here. So you have a car dealer that they would like to order cars according to the color preference. And people say, if, on average populations, they like all kinds of colors and there should not be any difference. So you expect that from blue, red, and white and black cars, I'm going to order 100 cars. And you just say, I expect everyone have random preference about color. So I'm going to order 25 blue cars, 25 red cars, and 25 for white and black as well. And then you start to take orders, and you observed is quite different than what you ordered or expected. So you probably have more people preferred blue and black, and less people preferred red and white. They all add up to 100, but the categories, the numbers that fall under each category is quite different. So chi-square test helps you to identify whether the model, your expected model, there is a statistically significant difference than your observed distribution of the frequencies in each category. And that's where you need to use chi-square test. So these are categorical variables, right? And then you are really saying that, among these categories, whether the distribution is similar enough to my expected model. And you will use this formula to come up with your chi-square value. And then you go to the critical value table for the degree of freedom. If you have 4 categories, your degree of freedom is 3. The number of categories minus 1. Then if you have too many categories, that means that your degree of freedom goes up, and your calculation becomes much more difficult because you're comparing, for example, 10 categories compared to what we have here for 4 categories. Then you have to have much larger chi-square value to achieve statistically significant result because you're comparing more categories. Okay, so this is where the degree of freedom is different than the one that we just talked about for t-test. T-test is really the sample size we are talking about, but chi-square here is not the sample size. It's degree of freedom depends on the categories.
So does that mean that the more categories you have, the less degree of freedom you have?
I would not say less degree of freedom. You will have less statistical power, and you will have to have a greater observed difference to claim that it is statistically significant. So it's not that difficult to understand, right? Because when you have more categories, there are more variables you need to consider. But coming back to this one, I would like you to be able to calculate. For example, I use the formula, right? The observed minus expected, square those up, divided by the expected. And for each category, you'll do this and then sum them up. The sigma means sum, right? First category, second category, third category, and then fourth category. And this is your chi-square value. Once you have chi-square value, then you go back to your critical value table, the one that we just showed. And in this case is, we say the degree of freedom in this case is number of categories minus 1. You have 4 categories, so the degree of freedom in this case is 3. And if you go to the table, you will find the critical value is 7.81. So mathematicians already calculated for you, as long as the observed difference is greater than this one, then you have a statistically significant finding. The observed distribution is not due to the chance anymore. People do have preference when it comes to buying cars. So then this is how you note your answer. So your chi-square value is 34.32, which is greater than the degree of freedom that you observed at 3 with 5% alpha level. Alpha level is also the significance level that we decide. In this case is the conventional alpha level is 5%. Okay. Any questions so far?
So you would basically only use the chi-square method for data that you can't take descriptive statistics of, correct? Because it's like a distribution versus something that has relevance is like a mean. Like if you took the mean of all of the people's cars, it wouldn't make any sense, right?
No, does not make any sense. And the chi-square is really for frequency comparison, right?
So that those are like variables that, or questions, I guess, or I think it's variables that have like levels that aren't related to numbers, right?
Hold on, your voice broke a little bit for me. So can you ask your question again?
You would use this for variables where they don't have any like number that represents anything, right? Like if it was a man and a woman, you could label them 1 and 2, but if you average them, it doesn't really give you any like.
Yeah, you don't average those things because
you wouldn't average
variables.
Right? That's why you use the chi-square, is because it gives you that like statistical difference you can like sort of compare. Is that right?
Yes. So what you're doing here is really you are testing your model. So your model at the beginning was like it's equal, and then observed is not equal, and saying that okay, next time when I order cars, should I change my model, or is it due to the chance and I can ignore the new observed frequency distribution in my categories? So
Gotcha.
what you're doing is really getting a sense of whether your expected distribution is good enough.
That makes sense.
So this kind of test is also called goodness of fit. So whether the expected model that you came up with is a good fit for the actual what happened in reality. And people often use this for, like, for example, you are predicting certain things for men and women. Okay. Then these are categorical variables. You can do that. And your students, you can use like girls and boys that you can predict that way. Or sometimes people could use this for election, right? So you probably have certain percentage already estimated for Republican candidate and like different parties candidates. And then you say the actual observed is how different is it ended up. You can always test your model that way. So chi-square test is always for categorical variables. And this is not directly related to your pre and post score, nothing to do with those, but it's also pretty frequently used when you need to have a prediction for categorical distributions. And you can use for your classes if you're teaching for like a gender or socioeconomic background or any of those. If it's important for you, you can think of using chi-square. Okay. So that's all I have in terms of this class. And I would like you to still go through each slide and read the examples and the explanations I provide under the notes section. And as I mentioned before, my lecture notes are the most important thing to do well in this class. And you can do additional readings, additional YouTube videos or Khan Academy videos if you are stuck at some concept, but it's not necessary, but you're welcome to do that. Okay, I think I will stop there. Any questions?
I have a question. This is Julia about the expected, the chi-square on the expected and then what you've observed.
Mm-hmm.
Do you use the chi-square? So I'm just trying to make sense in my brain with the real thing, which is I sell t-shirts and design and sell t-shirts, and they have different sizes. And I kind of know what are my biggest sellers. Like for my cat dad shirt, large is my biggest seller. But I don't really have a model I use. I just know that I order more of those when I print them up. Could I use chi-square
Yes.
if I don't really have a framework, a model, and just evenly distribute?
So you can certainly use that, but in your case, I assume that's a very good example. I would not use equally distribution for your expected. I probably will use your anecdotal observation first. For example, you'll say, okay, 60% of the people will order large, and like 20% will order medium. 10% will order small, 5% extra large, and the 3%. So just put your estimation first.
I got it. Okay.
Yeah. And then your observed will be the actual order that in certain amount of time. If you decide, okay, I will count up to 1,000 t-shirts, then you will just say, okay, among those 1,000, how many, what percentage really they observed, right? And then you see that whether your model is matching this enough. You can run this a couple of times and you can refine your model. And your model should get closer to the reality.
Why didn't I have this model before?
Now you know.
No, thank
That's
you.
a very good example. Yeah.
I have a question related to that example. Could you
Yes,
just
go ahead.
use historical data? Like, could you go back 1 month and use the exact numbers from that month to predict or try to figure out the next month?
Yes, you can always. And your expected frequency distributions or allocations by percentage can always differ as long as it's updated and most up to date. You can use and further refine that.
Gotcha.
Yeah. Good questions. Any other questions?
I guess I was wondering how this relates to our readings. Is this going to be in our book also, or is it mostly in the extra readings?
No, there is the books and the lectures are not one-on-one because we have to cover a lot of things. And what we are emphasizing the first few weeks are really the statistical foundations that you need to understand the very fundamental concepts like critical values, degree of freedom, p-values, hypothesis, and all of those. So I'm concentrating on that. But the books are the additional things that you need to know about assessment evaluation in general. So for example, Kirkpatrick's textbook That's even if we are not going to specifically talk about level 3 and level 4, you should still finish reading those because I expect you to understand and be able to use them in your future practice. So it's not a total new knowledge for you upon graduation. So the textbooks will not contribute directly to this, but the readings that related to this in video format are directly related to my lectures. So for example, if I gave you a 2 minutes video to check out under the reading and material section, you should read and click on those the videos. And there are some resources I provided probably under those category as well, but not the textbooks. There is no one-on-one correlation at all or association. Okay. So don't worry if this you still have some puzzles. You go back and study and ask questions, and you will get those at least like 90%. And I'm pretty confident you will be there. So would you like me to talk a little bit about the term project? Okay, so if you would like to go ahead and prepare for that, let's talk about the term project. So for the term project, yes, I would like everyone to use your 526 prototype if possible, but I realize it's not always possible. Some of you have never taken that class. You are on an alternative track. And some of you didn't do a lot of, your prototype does not have enough content. And that's probably, it's very difficult to come up with 10 test questions. I usually ask students to design at least 10 test items. Otherwise, it becomes not reliable. Your measurement is not going to be reliable, just asking a few questions. So minimum, develop 10 test questions to test the content or the skill or the knowledge. And you can pair up with another students, but I would highly encourage no more than 2 students will work on one project. When you have 3 or more students, so my expectation will also go up, and I would like you to test more students because I'm teaching a process in this class. This is a process-oriented class. So I don't care which prototype you are testing. If your prototype is not good enough, you can find a commercial prototype to test, which is totally fine. In the past, some students even used like Duolingo to teach French. That's totally fine. As long as you're learning the evaluation portion and assessment portion, that's good enough for me. So you go ahead and identify a prototype according to the requirements I put together for the term project guideline and decide. And I would like the entire test to be done in 45 minutes. So it's possible your prototype actual learning maybe 15 minutes. That is fine. But you'll also have a pre-test and post-test. Oftentimes, I often say that your pre-test and post-test should be identical, as long as you are not going to reveal your answers after they take pre-test. But if you think the pre-test, after taking pre-test, even without revealing the answers or without knowing the answers, will affect how they are going to score on the post-test, then you probably justify to have 2 equivalent forms of test. For example, if you're teaching addition, you probably had 1 plus 1 equals what for the pre-test. You probably can have 1 plus 2 equals what in the post-test. They are same difficulty level, same number of questions, very same format, just a little bit varied in terms of content, but the difficulty level is same. It's called alternative forms. So it's the same kind of test, it's just 2 separate sets of questions. Does it make sense? But in order to have a higher reliability, that as long as your pre-test, doing your pre-test will not affect any way they learn and do better and post-test, you can just use the same set of tests for both. For example, you are teaching some people about recycling. And even going through recycling questions, because you did not give feedback, you did not give the answer right after the pretest. Before they go through your prototype, your pretest did not reveal any of the answers. Then after go through the prototype, they can answer the same question set as post-test.
So, Dr. Sue,
Yes.
let's say you're presenting, you have a prototype class. You do the 10 question pretest. During the prototype class, I mean, currently from 526, I have like knowledge checks, which review the answers to the questions that I was going to ask in the post test. But in this case, I would remove those from the test.
No, that's not what I'm saying. So if your prototype has the practice items, that's totally fine, because you're asking them to practice the questions and able to retain the knowledge, right?
Yeah.
That's totally fine.
But even if they're tested on that same stuff at the end? Because mine's not numbers, mine's more concepts. So I say, is this true or false? And then I say, okay, you practice. Yes, that's true. Then they get to the post test and I ask them, is that true or false? They already got the answer from the knowledge check, not just from the information. That
is an interesting situation. So if exactly same, then it's probably problematic. But if you can justify to say that the post test they are going to take the next day, okay? So you give them sufficient interval to test whether the knowledge is retained after going through your module, after going through your training. I think it's okay.
Oh, okay. So we just do a little extension and see, now do you recall what you learned in that class 3 days ago when you take the post test?
Yeah, so what you're testing is, it really depends on what you're testing, right? If you say, okay, I'm teaching this knowledge and they had sufficient practice during going through the training, and after a while, I would like to know that whether this knowledge retained with them and whether it's effective to have students still know what to do after a certain number of days or certain number of hours, then I think it's justified to have the same questions. It's okay. It's really you're saying whether they learned or not afterwards.
Right. Thank you.
Yeah. So, and in terms of test subjects, I prefer you to have 10, minimum 8, but you do not need to do usability tests on all of those. You just need to observe and report on 3 to 5 users. So oftentimes people will do is they will send pre-test to 10 students, 10 test users. And then after everyone's pre-test scores in, then you will have a follow-up email to send them the link to the prototype or to the evaluation product. They will get trained, and if you would like to observe, you can observe in person. If they are remote, you cannot observe in person. Students used to use Zoom. You ask them to share their screen where they're clicking and speak up what they are thinking, right? Think aloud method. And okay, I'm going to go to here, and that's where you are observing whether your navigation is intuitive for them, whether anything they're puzzled. So usability is really the intuitiveness of your prototype, right? And by observing, you can tell a number of things. And your observation checklist, besides the major categories you are observing and noting what problems occurring, often also has time. whether they spend adequate amount of time on each page, or they are so lost that they have to revisit, or they are so lost they stay longer trying to get out of that page, right? All of those things are information coming to you in terms of your prototype. So the observation checklist you have to design. And sometimes if you are testing a website and information architecture is something you probably would like to know, for example, and in that case, you will need to design the tasks for your observation checklist. For example, you say, go ahead and find the telephone number of this company. The way you are giving this task is to observe whether the information architecture when you design this website makes sense or not. Students probably go to About Us to find it, or go to Contact Us to find the number. By observing them where they're clicking, you are able to tell whether the navigations, the way that you categorize them, making sense or not, right? So it's really testing how quickly they are locating to the information they need. And that is for testing a whole website. But I'm assuming that in your case, it's usually a prototype. It's probably sequential already. And the navigation is probably from one page to the other and does not have a lot of different sections yet, which could be a different story when you get to your capstone. Because when you get to your capstone, you probably have a lot more categories, more modules, and you probably use a website to host them. That's why I'm just mentioning that if you have more things, that's not only one prototype anymore, then the observation checklist may have more things than what you probably will be using for this class. Any questions?
I have a couple of questions. For our pre and post test, is that where we would include any like demographic questions for the survey?
No. So besides your pre and post test, your pre and post tests are always content and knowledge. That's a level 2 evaluation you're doing. You are measuring whether people learned or not. But for usability, besides observation, you often have a usability survey, or we also call questionnaire.
Yeah.
And that at the end, you will ask their perceptions. That's level 1 evaluation. As long as you're asking perception level questions, you are not testing their knowledge.
Yeah.
You're asking their preference and their experience, then that's level 1. Probably your questionnaire about usability becomes, how did you like the color of the prototype, right? Whether the audio worked out for you.
What if we want to analyze the pre and post test scores against the student's background? Like did male or female students do better, or did students of a certain ethnicity do better, or?
That is a pre-survey. So there are a few things you need to design, right? All the instruments. Okay. You have to have a pre-test and post-test. You have to have checklists to observe. You have to have a post-survey, which is your usability survey. Oftentimes, you can have a pre-survey for the demographics. Okay. And a lot of times people combine the pre-survey with the usability post-survey. So you can ask all of those demographics on the same survey that you ask them to fill out after they have done the prototype. You can do that. It depends on how you design your instruments. That's all fine.
Gotcha. And then my next question is, so I haven't taken, I think what you're calling it 526 to build a prototype, because I'm a part-time student. I know there's quite a few of the part-time students in this class. Should we find so I know you gave one example was Duolingo. Are there a list of other examples of like lessons that we can, or things that we can have them use, or should we design that? You
don't need to design. This is not production class, so please do not spend time to design anything. Just go ahead and use an existing prototype. You can identify anything that's instructional in nature. You cannot just have informational website. You cannot say, okay, I'm going to go to AAA's website and evaluate this. No,
Okay.
because it's informational website. The thing that you are going to use has to be instructional in nature. That means it needs to teach something, and I also have the interactive feedback features inside.
Okay. You don't have a list though of like other things that would work, or should we just like submit some ideas to you and you can give us a little bit of
If you are unsure, you should check with me. But
Okay.
oftentimes it's not that difficult to find instructional materials.
Okay.
And I would like you to search and decide what is beneficial for you and what kind of users you have access. So it really depends on what prototype you would like to test. And oftentimes students pair up with people who have a solid prototype to test.
Gotcha. Thanks.
Yeah.
So-
So help each other out. If some of you are in the same team, and it's good to have another person because that person can split up the work, and probably you can each observe 6 students instead of you alone doing 10 students, right? So there's a pros and cons, but I think the merit exceeds everything else. Mark?
So in other words, we could, for instance, my website, getupandmove.net, also has an activities page, which shows all the training videos and all the activity videos. I could do it where I'm testing to see whether people that once they watch the training videos, whether they're able to do the exercises. And
Mhm.
once they watch the orientation, whether they know the knowledge of the value of movement. So I could do it using my website as a sample, right?
Yes, anything that has instructional components and they will learn and also practice, and has that feedback features. So
And then for a
after
post
your-
test,
yeah,
for a post test, I might observe them doing the movements on their Zoom to see if they actually learned them
of course.
from the
yeah.
website.
So it's totally fine. You just need to design the appropriate test items that will measure the thing that you taught.
That's what I would design in this class in order to create a measuring ability to do a pretest and a post-test.
Right. So it could be anything, like PE, psychology, anything that's you're teaching, and it has to be appropriate. That's why in your report, you need to give me access to the prototype you tested and all the instruments, including your test activities, test subjects, and test questions. And I have to grade your instruments against the thing that you taught. So if you're teaching movement and activities, I will have to go and watch and see that whether the instruments you produce are really measuring what you're teaching. That's the thing we're talking about, right? So if you're teaching math, your pre-test and post-test have to be the same level of math you're testing. So the kind of instruments you're producing have to make sense. And you will be graded on those items. Okay. Any other questions?
Has anyone ever used a learning instrument that they wanted to prove didn't work?
Yes. So some students were so confused. They didn't quite understand how level 1 evaluation and level 2 evaluations are different. So even after their for even level 2 evaluation, their questions are perception level questions, and I have to mark those down, and I cannot give you credit for those. For example, you taught math. Your pre and post test should be the math problems. But instead of math problems, some students pre-test and post-test saying that, did you like the math problems? Did you enjoy the math problems? Did you understand the questions? That's not level 2. That's not test questions, test items. That's level 1 perception. Whenever you ask it about their opinions, it becomes level 1. So I would like to see both level 1 evaluation, which is your usability surveys in this case. Level 2 is actual test items that you come up with to test the effectiveness of the things that you taught.
Is it unethical to give people instructional materials that you think are not adequate?
What do you mean?
Well, for example, I help adult students with HiSET, and the video that comes with that would accompany the book or to prep for the test is really inadequate. So I think it would be interesting to measure how little learning happens. I mean, maybe you would have to use two tools. Maybe you would have to have two groups and compare the same subject matter being taught, through one set of prepared materials and another set of prepared materials.
It's if you're comparing that, yes, you do need to have two groups to compare their result. It's you have a control group to your research group to see that whether the materials, it's misleading for people to understand the content. Yeah, but otherwise I don't think you can come up with any conclusions without comparing, right?
Right. Yeah, thanks. No, it's just, it is pretty amazing that the instructor will be on the screen talking about something and the symbols that are on the screen are not what the instructor's talking about. And so people visually are processing information and the instructor's talking about something else.
Okay.
That's stuff that we learned during Zoom and students trying to learn from videos, so.
I see. But for your term project, you just need to have one group.
Yeah, okay.
Testing and
Yeah.
post. And we'll talk more about what to do when we get to week 3 and 4, and how you can compare those within same students, right? Pre and post test. You'll compare the same students pre and post test and
Yes.
to see whether there's improvement or not.
Yeah, okay, thank
Yeah.
you.
Any other questions? If not, we used up. We are 15 minutes over. And always ask questions on the Q&A forum if you have any questions. And if you know the answer, also help answer if I'm a bit late answering. So that's where our learning community can help each other. Okay, if no more questions, I have another meeting with another team. So I hope that they are not waiting too long. Okay. So bye everyone. I will see you next Thursday.
Thank you.
Okay.
Bye.
Thank
Bye.
you. I'll stop recording.
Can I ask a quick question?